recording now. Okay, now recording has started, right? So I start recording on the example. Okay. So the example, the first one, dy dx minus xy equal to e power minus x squared y cubed. So this is an example. Let me copy this example here. So hopefully this will be at least in YouTube lah. Okay. So I want to copy this example, then put it in YouTube here. So example 3. Okay. Example 3. Bernoulli equation. So this is the one I'm interested in. So Bernoulli equation, example 3. So I put it here first, and then I need a few more pages, so at least 2 more pages. So this is the question. So the way to solve this equation, first of all, how do you know this is the equation here of the type here? So compare this one, okay? Compare this one with the equation. I have dy dx plus px times y equal to qx times y power n. Compare this equation. So when you compare this, you find that this is the Bernoulli equation. Why? Because you have a minus x is your px now, and qx minus e power x squared is your qx now, right? What is n now? N is equal to 3 now. But compare this equation, n is equal to 3. Okay, so this is a Bernoulli equation. Okay, the n is the degree here, is equal to 3. So what you do is divide both sides by 3. No, divide both sides by y power 3. Right? So divide both sides by y power 3. Get y. So divide both sides now. By y power 3. So then you get 1 using this standard equation as a reference here. Divide by y power 3, you get y power minus 3 dy dx minus x. Okay, 1 y power 1 divided by y power 3, you get y power minus 2 now. And then the other side, after divide both sides by y power 3, you get e minus e power minus x squared. Right? You get this equation. Then to solve this problem, then you have to let u equal to this thing. Look at here, this one. Okay, u equal to this one. So I let u equal to this one. So I just write here first because u equal to y power minus 2. Okay, this is how I'm going to simplify this. I want to get rid of all the y, and so that final equation have only u and x. Okay, so this equation I leave it there. So let's do a simple calculation first. Okay, so I start from original problem, compare what is the standard Bernoulli equation first, divide both sides by y cubed. Okay, then you get y minus 3 dy dx minus x y power minus 2, and then on the right hand side negative of e power minus x squared. And let u go to y minus 2, right? Y power minus 2. So let's do this, how to make use of this. Right? I'm going to show you how to let this. Okay, so my u is equal to y power minus 2. So how do you find differentiation of du dx? Of course, using the chain rule, you can differentiate. Okay, du dy first, then times dy dx. Okay, this is chain rule. Okay, chain rule. Now u is y power minus 2. So this differentiate y power minus 2 times dy dx now. Okay, so differentiate y power minus 2 using the power rule for differentiation. You get minus 2 y power minus 2 minus 1 and minus 3. Okay, so this is normal differentiation. Okay, differentiate y power minus 2 with respect to y. Then you got this. So this is du dx. So from here, what is actually dy dx now? So dy dx is equal to divide by minus 2 first, then multiply by y cubed, right? Then you get minus half du dx is equal to dy dx now. So dy dx is minus half y cubed du dx. Why is this useful? Right? Later on, I show you the why is this useful. Okay, so you start from u equal to y power minus 2, then you apply the chain rule. Okay, then differentiate u, you get y power, which is y power minus 2. You differentiate, you get minus 2y power minus 3 du dy dx. Then make dy dx the subject here. Now I'm going to go back to the earlier equation to show you why this is useful. Okay, earlier equation is this one. Okay, earlier equation I have this one. Okay, this one is my earlier equation. Okay, involving y and x. I want to get rid of y now. Okay, so let's put here the earlier equation. So I need a new page here. So this is earlier equation, and my u is y power minus 2. I also have just now dy dx. Okay, dy dx is this one. Okay, let me copy this one. And dy dx is this one. Okay, so notice that what is dy dx now? Okay, dy dx is actually, okay, dy dx is this one, right? You can see the dy dx is here. Let me put a color, put a blue color here, put a blue color here. Dy dx is this one, right? Okay, this green color one is u. So now I put dy dx here. So this is equal to y power minus 3. Dy dx is minus half times y3 du dx. Okay, the dy dx is actually this one. And then the other one is minus xy. So minus x, y power minus 2 is u here. Okay, y power minus 2 is u here. So I use the green color one. So I get just substitution. And this is equal to minus e power minus x squared. And you have a log cancellation, right? You can see that y power minus 3 and y3 cancel. So you get minus half. Okay, so you get minus half of du dx minus x times u equal to minus e power minus x squared. Now I multiply minus 2 to everywhere. Okay, multiply both sides by minus 2, so that the number in front of du dx is 1. Okay, so you get du dx minus x times minus 2, you get 2x u. Okay, then minus 2 times minus 1, you get 2e minus x squared. So you get this equation. So this is the equation in u and x only, right? In u and x now. No more y. Okay, no more y. So we are trying to solve this equation in u and x now. And this is the type equation you can compare how to solve this. So after they got this already, so we have to recap again what is a linear equation. Remember what we have. Okay, I'm going to write this and let you compare. Okay, so select the 2 here. I want to copy to the next page here. No, sorry. So copy this one first. Go to the next page. Okay, I think this example is unexpectedly long. So here, now you compare, right? Now you compare something you already know. Okay, compare the equation dy dx plus px times y equal to qx. This is what in the chapter 7. Okay, chapter 7 we have something like this. So how do you compare now? What is a px now? You can say, alright, so from here I know px is equal to 2x now. Okay, your y become u now. Okay, you're solving for u now. Okay, px equal to 2x and qx is equal to 2e negative power x squared. Okay, so how do you continue with this type of equation? This is called a linear equation. So you find integrating factor, which I think we learned in first year. Anyway, just remember integrating factor is e power px dx. So integrating factor, your px is 2x now, so the e power 2x dx. So integrating 2x, you get x squared. Okay, just using power rule, x squared. And when you do integrating factor, you don't need the plus c after integration. Just this is your integrating factor now. So after you do integrating factor, so you plug this into the original equation now. So I'm going to multiply everywhere by integrating factor. So what you have is e power x squared multiplied by du dx plus 2x e power x squared. So multiply by integrating factor, multiply by u, and then multiply by e power x squared. Everywhere multiply by e power x squared, which is integrating factor. So and then you left with 2. Okay, 2 times e power minus x squared. Now, then you find that this e power x square and e power x square, they obviously cancel each other. And the left hand side, you combine as differentiation of one term. What is that equal to? Differentiation of e power x square times u, and then equal to. So the u is the one you select here. Okay, u here. You select u here. You select e power x square here, and then multiply them. Then you should get the equation above by using product rule. Keep the first term, differentiate second term. Then you keep the second term, differentiate first term. Alright? So you can get until like this. Then to find the final answer, you integrate both sides now. So that means that eventually you get e power x square times u is equal to integrate 2 with respect to x now. So this will give you e power x square times u equal to 2x as a constant. So put it back together on the next page. Okay, on the next page, e power x square times u equal to 2x plus c. So on the next page here, okay, e power x square times u equal to 2x plus c. So you can find out what is u here. Remember, u is beginning y power minus 2. Okay, remember the here u is y power minus 2. Okay, the green color one. So that means that u is 1 over y squared. So that means e x square 1 over y square is equal to 2x plus c. That means that y square times 2x plus c is equal to e power x square. And so eventually y square is equal to e power x square 2x plus c. And this is the final answer. This is the final answer given in the notes there. Check the answer in the notes there. Okay, y square equal e power square 2x plus c. Right? This is the final answer. So this is how you answer example 3. So let's see if anybody got a question. We can see the notes again. Anyone? No battery. 红字是 absolutely no battery. Okay, so if you need anything, I can go back to show you. Previous page for a while. Okay, sure, no issue, right? Previous page for a while. Okay, previous page. This is the previous page here. Okay. Okay, anymore. Alright, so any request? So this is example 3. The method is quite standard. After you go through a few rounds, you will do that. Oh, this is the type of question you do all the time. Okay, so this is example 3. Right, so I'm going to show you example 4 later on, right? So example 3. So example 4 now. So look at example 4. Is it easier? Have a similar pattern. Alright, example 4. So the question is like this. Okay, this is again the type of question, very similar. Okay, is it the similar? So if not sure, let's try write it this way. You have dy dx plus px times y equal to qx y power n. Okay, this general Bernoulli equation look like this. So by looking at the comparison, so what is a px now? So the px is actually 1 over x here. Where is the qx here? Qx is 1. Okay, qx 1. So basically, you have qx which is 1 now. This is 1 over x. And n is equal to 3. N equal to 2 now. So you know that this is the Bernoulli equation. So how do you solve this Bernoulli equation? You just divide both sides by y squared, right? So based on this, divide both sides by y squared. Okay, by y squared. So when you divide both sides by y squared, you get 1 over y power minus 2 here. Okay, so this 1 over y squared, 1 over y squared dy dx, then y divided by y squared, you get 1 over x and 1 over y. 1 over y is y power minus 1. So maybe I just put them as y power minus 1 first. First, you can see color, and then left with 1 after divide both sides of y squared. And what you're going to do is, alright, I'm going to take this as my u here. Okay, take this as my u here. So let u equal to y power minus 1. Okay, so compare with the equation. After you know that, okay, divide both sides by y power n. N is equal to 2 now. So divide both sides by y power 2, then 1 over y squared dy dx plus 1 over x, y power minus 1. So, and let u equal to y power minus 1. Just follow the step. Okay, it'll work. Okay, that's right. So, and let y equal to u power minus 1. So how do you find dy dx now? Dy dx is equal to, we know is dy du times du dx. Okay, this is called chain rule. But what is y? y we now know that is in terms of u is u power minus 1. So differentiate u power minus 1, you get minus 1 times u power minus 2 now. So this will be minus 1 over u square du dx. So now make dy dx. Okay, I already have dy dx. Okay, so dy dx is minus 1 over u square. I want to replace it. Okay, so that means that all the dy dx I'm going to be replaced by minus 1 over u square du dx now. Okay, so then go back to an earlier equation. So this is what I have from the earlier equation. So let's, what is earlier equation? This one, right? So this one, standard equation, I look at this equation here. Okay, this is the equation. Let me copy it to here. So insert here. This is the earlier equation. And now I know u is equal to y power minus 1. This is the green color one. And then the other one is what is the dy dx now. Okay, I want to replace everything, the y disappear. So replace this one where dy dx is equal to minus 1 over u square du dx. So copy this one, move to here. Eventually you don't want any y. Okay, y will be replaced. So let's say I change the color here, this blue one. So dy dx is changed now, right? So dy dx is equal to 1 over y square, okay, minus 1 over u square du dx. Now remember, u is u power minus is u here, so this one is y here, this one is dy dx, okay, and this one is u here. How about y square? Okay, remember, u is actually 1 over y. Right? So 1 over y square is actually u square. So because I say I don't want any y there, right? So 1 over y is u. So u square 1 y square, right? So I don't want any y, right? So this 1 over y square is actually your u square here. So this u square here minus 1 over u square du dx plus 1 over x times u equal to 1. So I have u here, and then the rest they got cancel. They cancel away. So you have the equation finally as negative of du dx plus 1 over x times u equal to 1, which is saying that du dx minus 1 over x times u equal to minus 1. Okay, this is the equation in u and x now. Okay, no more y. Okay, all the y will cancel away, eliminated. So no more y now. Okay, now how to solve u now? Just recall again how to solve the standard procedure again. du dx minus 1 over x u equal to minus 1. Standard procedure, right? So this is du dx minus 1 over x u equal to minus 1. Okay, the original equation. Now, standard equation of this is using this one, right? dy dx plus ex times y equal to qx. Standard first order linear equation. So by comparison, your y is a u now. Okay, and px is equal to minus 1 over x. Qx equal to minus 1. Okay, by comparing, okay, this one, so minus 1 over x is your px now, qx is minus 1. So how to continue this type of equation? You use integrating factor. Okay, integrating factor, usually we use mu x here. It's e power integrate px dx here. So we integrate e power minus 1 over x dx here. Okay, integrate minus 1 over x, we know is ln x here in minus sign. Okay, negative power, basically you have means upside down. Okay, e power minus ln x is 1 over e power ln x. And e power ln x, we know is simplified, is x here now. So you have to remember e power ln x is x. Okay, so e power x squared get back x squared, e power x cubed get x cubed. E power ln x cubed get x cubed here. E and ln are inverse function of each other. So now I get this integrating factor. Then what next now is multiply both sides by integrating factor. So multiply by 1 over x. Okay, this side multiply by du dx here minus 1 over x again, multiply by 1 over x u, then multiply by 1 over x again, minus 1 times 1 over x and minus x here, multiply by integrating factor. So I can put it this way. Here, let's use the same color one, right? Multiply by integrating factor. Then the left hand side can combine. How to combine? If you do it correctly, then you should get this one and this one together. So you get differentiate 1 over x times u. Okay, you can check that this actually works. Okay, the one on the equation on top there is just by differentiating the bottom using product rule. Okay, keep the first term, differentiate second term, then keep the second term, differentiate first term. You get back exactly the equation on top. So what is this mean now? This means 1 over x now times u is equal to integrate both sides 1 over x. Okay, so this is just by integrating both sides here. So how to integrate minus 1 over x? We already know already. This is 1 over x u over x here times minus 1 over x ln x plus c. I think this is maybe the lowest I can get. First, u over x is minus ln x plus c. Then you put the u back, okay? Put the u back. Okay, u over x equal to minus x plus c now. So u over x equal to minus x minus ln x plus c. Now u just now in the very beginning, u is y 1 over y, alright? U is 1 over y here. Okay, y power minus 1. Okay, 1 over y here. U is 1 over y. So okay, this is the beginning we have. So that means u is 1 over y here, 1 over xy equal to minus ln x plus c. So what is y now? So y is equal to, okay, so 1 over x times c minus ln x, you get y. And if you look at answer I think is this one, right? Same as the answer here. So answer is here x c minus ln x. Yeah, so this is the answer here. So this is how you get this part. Okay, so to wait for you. Any question for this part? This is called Bernoulli equation. How to solve Bernoulli equation? To start, divide by both sides by 1 y power n. Then you do chain rule. Then replace the u, du dx. Okay. Very systematic or routine, and basically quite routine here. Yeah? Let's see any question. So this is the example on the Bernoulli equation, right? Example 3 and 4. Okay, if this no issue, and move on to the last type of differential equation, right? Last type of differential, first order differential equation. So I'll need quite a bit of explanation because this different type of differential equation now. Okay, this is called the exact equation. Let's refer to the notes first. exact equation. Alright, so what is an exact equation? Exact equation is something like mxy dx plus nxy dy equal 0. So again, okay, this is an exact equation. How do you know this is an exact equation? Let me say something about this special equation. So you have an exact equation. Look, let me write here. Exact equation. So we just get something like mxy dx plus nxy dy equal 0. So this equation actually looks a lot like homogeneous equation. Okay, so in some sense look very similar, but the form is similar, but actually this equation is a lot easier to solve. So where, okay, mxy is this one. So I want to say this is an exact equation if there is a function for x and y such that differentiate this function with respect to x, get mxy, and differentiate this function with respect to y, get nxy. Okay, if you have this function, differentiate with respect to x, get fxy, differentiate with respect to y, get nxy, then this function, this equation is exact. Okay, the problem is, how do you find this function? Can you find this function easily? Okay, the question is, how do you find? How do you find this function? Differentiate with respect to x, get m. Differentiate with respect to y, get n. Okay, one way to check, okay, is to, how do you check this? You just check, okay, how to differentiate function m with respect to y. Okay, function x with m with respect to y means differentiate m is differentiate. You actually differentiate this one. You can find that this is actually, okay, actually differentiate the function 2 times. Whereas, how do you check the other one? Let's say if I differentiate n with respect to x now, so this is actually differentiate with respect to x of y 2 times this is equal to differentiate the function with respect to y, and we know that these two are equal. So to check that whether you have an exact function, it's very easy. You check this function. You check this function, is it equal to this function? The partial differentiation with respect to n, and partial differentiation with respect to n, with respect to x. So are they equal? So this is how you know whether he has a function. You just check that whether they're equal. Okay, that means that the whole thing is exact if this is equal. Partial differentiation of m with respect to y and partial differentiation of n with respect to x. Are they equal or not? If they are equal, this is exact equation. Okay, if they are equal, then this is exact equation, and from there, what is the solution now? Okay, so the solution, if this is exact, then basically the whole equation, if you look carefully now, okay, the whole equation, the solution is, let me do another one. Okay, I have to talk about this because I think you have probably forgotten the partial differentiation again. So okay, so first of all, let's try to understand this. Okay, this is a total differential thing. Okay, a total differential thing. Okay, so if, okay, for example, this is a function of x and y. So total differential of this thing is equal to partial differentiation with respect to x dx plus partial differentiation of with respect to y dy. Okay, so in our case, this is actually m. The other one is n. And you say that we have this equation equal to 0. Okay, our equation is, this equation is equal to 0. Alright, so if this is equal to 0, so what does it mean? That means that d is equal to 0. So therefore, answer is, this is a constant. Okay, so the solution is actually, this is a constant. Replacing using this one, right? So let's check again. How do you know the function is exact, right? So first of all, we know if this is exact, there is a function partial differentiation with respect to x, you get m. Partial differentiation with respect to y, you get n. Okay, how do you know that they are exact? You just differentiate m with respect to y, differentiate m with respect to x, you see whether they're equal or not. Because if they are equal, then they are exact, right? How? Because when you do partial differentiation with respect to x and y, or partial differentiation with respect to y and x, they make no difference. Okay, so therefore we know if this is the case, then you have a exact equation mxy dx plus xy dy equals 0. So that means that this is a constant. Okay, so example, how do you actually solve this example? We only have one example because they are all similar. Okay, so just move on to the next page and show you the example. So this time we have an example. Okay, this one, 2x plus 3y dx, or 2x plus 3y dx, 3x plus 2y dy equals 0. Okay, so this is a question. Solve this equation. Okay, so sometimes you just have to guess what kind of equation is this, because by looking at it, this type of equation could be homogeneous as well. Okay, but homogeneous, I think you know, is quite hard to solve, right? Because we have an example earlier. I think you have to do long division, do partial fraction, quite long, right? So maybe you check the easy way out first. You can say, all right, let's check whether this is exact first. Let m first, m equal to mxy equal to 2x plus 3y. Then nxy equal to 3x 2y. Right, so hopefully that this is exact. How do you know this is exact here? So the first one is differentiate the m with respect to y. What do you get? Okay, differentiate with respect to y. Differentiate with respect to y. 2x becomes 0. 3y becomes 3. So this is 3. Differentiate n with respect to x first. Then you also add 3. 3 differentiate 3x get 3. Differentiate 2y get 0. So this is 3. So you find that partial differentiation with respect to y is the same as partial differentiation with respect to x. They're equal. Okay? This is what I mean. Look at the first page here. Okay? What I mean that this is the first page here. Things here. Okay? Partial differentiation with respect to y. M with respect to y. The same partial differentiation of m with respect to x. See again, right? This part. So because of this, we check. So this is exact. Straight away you know that this is exact. Okay, so this is an exact equation. So if this is an exact equation, how do we find the answer? So what is phi now? What does this phi stand for? Okay, it means that there is a function phi, partial differentiation with respect to x is equal to m. So that means if you check this, there is a function phi here, differentiate with respect to x here m. Okay, let's try this. So that means that there is a function of two variables, partial differentiation of x is m. Now we know m is equal to 3x plus 2y, right? Oh, sorry, m is 2x plus 3y. M is equal to 2x plus 3y, right? So how do you find this function now? So partial differentiation with respect to x to 2x plus 3y. So what is this function? You just integrate with respect to x here. So integrate 2x plus 3y with respect to x. Now, when you do partial differentiation, your y is a constant, right? So same thing. When you do integration, your y is constant now. Okay, y is constant now. So when you integrate 2x, your x squared. Integrate 3y, where y is a constant. So in this case, with respect to x, 3y constant now. So constant 3y, constant times integrate with respect to x, you get 3yx here. Then finally you have add a constant, but this is a constant, is not a number. The constant is a function of y. Let's call it fy. Okay, this is also a constant, right? A constant in x, yeah, because you have the integration, you add a constant. This constant is a function of y now, because when you differentiate the whole thing with respect to x, you get back 2x plus 3y. Okay, because you can check here. Let's do one more time here. Let's see, you have differentiate with respect to x now. How to get this one? You get 2x. This one you get 3y. Then this one you get 0. 2x plus 3y, right? So you know that this function actually is x squared by 3xy plus a function of y. Okay, so this function, if x squared plus 3xy plus function of y. Okay, so this is your m, using the m here. Okay, so then there's missing information because we only use this part to find m, using the m part. How about the other one? Okay, so let's try the other one now. Okay, we also have partial differentiation with respect to y. Okay, supposed to give you n. So what is this equal to now? Okay, we will find out that this is equal to x squared. Okay, this is equal to x squared plus 3xy plus fy. Okay, x squared plus 3xy plus f of y. On the other side, what is n now? N is integrating, n is 3x plus 2y. So n is 3x plus 2y here, so you make use of that. 3x plus 2y. Okay, you know this. So just now we do differentiation, right? Integration. Now I'm going to do differentiation, right? So earlier step, this is integration first. Okay, integrate first. Integrate first. Now I actually differentiate with respect to y. Okay, earlier I do integration with respect to x. Okay, integration with respect to x here. Now I integrate differentiation with respect to y. So what do you get now? So you get differentiate with respect to y. X is constant now. Then you get 0, 3x, what? 2x constant, right? Differentiate y with respect to y, get 0, and then you get f prime y. And then on the right hand side is 3x plus 2y. So from here you can calculate. Okay, you find out this 3x and this 3x cancel. So f prime y. So you find out that f prime y is equal to f prime y is equal to 2y. So f prime y means differentiate y, you get 2y, right? So that means that y is y now. The function f differentiate the f, right? That means that differentiate with respect to y, you get 2y, right? So where is fy now? Fy integrate both sides, of course you get y squared. Because differentiate y squared with respect to y, you get 2y. So fy equal to 2y plus a constant. So I know that, okay, so this function is first is x squared plus 3xy. Okay, going here now, plus fy. Fy is y squared. Okay, so the solution is what? Solution is just this is a constant. So solution of this is constant means that x squared plus 3xy plus y squared plus c is a constant. So c being over, this is constant. Okay, so this is how you do the exact equation. every exact equation can be done in this way. Okay, but the moment you know that this exact equation, you can do it this way. So what is the exact equation? Let me put it back first. The exact equation, the first thing basically is there must be a function, differentiate with respect to x, you get m. Differentiate the function with respect to y, you get n. Okay, then you check, differentiate the m with respect to y, and differentiate n with respect to x, are they equal or not? If they are equal, then you have exact equation. And the solution is using the total differential. So this is the same as equal to 0 means the total differential is equal to 0. That means that this is a constant function. So to do this, example 5, first check this is exact first. Yes, we find that this is exact by checking this partial differentiation with respect to y and x. Okay, make sure that you do the correct partial differentiation. So because this example is quite tricky, the partial differentiation with respect to m also, I mean this example is also tricky, you know, because but if you do differentiation of m with respect to x, you get 2. Differentiation of m with respect to y, you also got 2. But this doesn't tell you this is exact. Right? This is not correct, right? If you do this, although they are equal, but equal in the wrong sense, because it doesn't tell you that they are exact. So you must differentiate correctly. And then, okay, just say this is not exact. This is not exact. This does not imply exact. So you make sure that you do a correct differentiation. Okay, then once you know that exact already, so the first thing you can integrate the function. What is the function look like? I don't know. So let's say this is m now. Then integration just like differentiation. This difference you want to integrate with respect to x, you treat your y constant. So after integration is a constant, but you might remember the constant is a y term. Okay, so this is just for checking now. This part checking. This part for checking only. Okay, then after integration with respect to x already, then you differentiate with respect to y. Okay, then you'll find out what is fy. So from there, you conclude what is the final solution. And so let me see, anybody got any issue here? No. For this chapter 7 and chapter 8 tutorial, you can try a few, but okay, you try as many as possible because I think you need a lot of practice on integration. Basically all of them are integration problem, so you need a lot of practice on integration. And the solution, most of them, the solution is in the blackboard already, so there is no issue that you cannot do. I think because almost all of the question has solution in blackboard, only except a few new one, no solution, which I will discuss. And then when you next week, some of the solution which you will not have, you cannot find any solution, then I will discuss it, okay? Because most of them have solution in the blackboard. Okay, so today my lesson will end here. Okay, the time you can try the tutorial question. So I'm going to stop recording already. Hopefully this one will show up.